Our world is changing. Natural and built environments are constantly evolving and interacting. We witness miracles and wonders, dangers and disasters. Technological advances help us understand our world and inspire new responsibilities. We have sensors of all kinds, from rain gauges to satellites, observing and measuring changes. Sensor data, maps, and location information stream across our networks. But we still have trouble sharing and combining data from different sources, turning it into information and knowledge so we can make smart decisions. Guided by an imperative for interoperability, the Open Geospatial Consortium has been advancing open standards for sharing geospatial information since 1994. The OGC's innovative process uses testbeds, pilot projects, and interoperability experiments to provide rapid development, testing, and validation, leading to the adoption and evolution of standards. This is not just about integrating technologies. It's about understanding and overcoming institutional barriers to sharing information. The OWS-8 testbed is based on a fictitious earthquake and oil spill in the Monterey Bay area of California. We will look at some of the key issues that arise when everyone from first responders to national agencies seek to acquire, synchronize, and maintain a complete, current, and accurate picture of the situation. Buildings, roads, and utilities are damaged. An offshore oil well has ruptured. Emergency responders need to work together to quickly assess the damage, notify authorities, and respond to people who need help. The OGC's OWS-8 testbed began with careful planning, followed by software development that started in March 2011. Accomplishments made during the next 6 months were captured in the demonstrations and reports you can see on OGC's website. All of these are freely available to the public. Data pours in from national, regional, and local sources, but each type of user may use different structures and styles for expressing their data. In this testbed, we developed advances in semantic mediation to work with OGC's catalog services and web feature service standards for data discovery and access. This strategy allows users to mediate between information models, converting data types and symbols from one model to another. Real-life GIS users can benefit from the advancement of semantic mediation for data exchange across different communities. During an event like this, it may be necessary to perform bulk data transfers between headquarters and field operations. The advance in this testbed allows transfers of huge quantities of data across different database systems, from government to private sources, using both commercial and open source software. It also shows how field users can update and synchronize their data with an emergency command center. The first solution uses Esri's file geodatabase with zip compression for organizing and packaging a large dataset to be exchanged. This was unpacked, edited, and returned using the OSGeo and PostGIS open source map editor and database. The second solution uses a dataset encoded with OGC geography markup language, zipped and served using OGC web feature service standards to organize and transfer the bulk data. These advances enable first responders, warfighters, and other users in the field to send and receive near real-time data, providing situational awareness as well as reporting actual changes as they are happening. Another testbed activity demonstrated an approach for sharing and enhancing data about moving objects. a capability that has previously been limited to costly proprietary software systems. MISB and OGC standards can be used to describe a moving object in a video stream. This description can then be compared to the description of a moving object in another video stream to see if they are the same object. This advance can be utilized in many government and private sector applications for public safety and to track the movements of critical resources. Sponsored by ESA and NASA, the OWS-8 advances in Earth observation coverages greatly increased the Earth observation community's support for WCS 2.0, an Earth observation profile of WPS and WCPS. Sponsored by the FAA, Eurocontrol, and NASA, OWS-8 aviation activity advanced aeronautical and meteorological information exchange models, which now incorporate OGC encoding and web service standards. These advances will help the FAA SWIM program and CSAR's SWIM environment realize a global vision of next-generation aeronautical information management capabilities. More than ever, people need to be able to communicate location information, and that's the reason for the OGC and our yearly OWS testbeds. Insights gained, gaps identified, and lessons learned in all of the OWS-8 functional areas form the basis for the next testbed, OWS-9 in 2012.